Yeah.
Okay.
Now, fine, I'm gonna start.
Okay, I hear you. How's the microphone? How's the setting?
Yeah, very good. I think that the microphone is fine. And yes, very good. Please, continue.
Okay, so on Friday, for those in Daytona Beach and the 3 who showed up at the end for my being in the wrong room, we were talking, essentially the upshot was know your data. And so we talked, just a quick refresher, we talked about where the different sources of data, and at the very end, we discussed know your data. And today, I want to do something a little bit different. We're actually going to work with, hi everyone in Daytona, I see you there. We're going to actually look at using Weka. So I'm going to share the screen here. Hopefully this works.
Okay, now good.
Oh, whoop, I did.
There you go.
Okay, now it should be.
Yeah. Yeah.
Okay, so back to that.
Okay, so this is, so I'll back up a bit here.
Yeah.
So we just brought up Weka, and this is the first screen that you're going to see, this little screen on the left-hand side, and we're then going to just choose the Explorer. Is that coming up?
Yeah, we can see it, yes.
Okay, so now we're going to, up on the left, there's Open File, and we're going to click on there, and then at the bottom, you notice the file types, your standard interface here, and these are the different file types, and we're going to start off by opening up a .arff file. So when you save the file, it's got to be saved as a .arff. And so we're going to bring that up, and I'm going to go look for it. And notice I have 2 there. I'm going to bring up weather. So this is going to be the first thing that you see when you open up the file. Over here, so on the weather file, we have 5 attributes. They're labeled here. We can look at the actual file. We can take a look at what that actually looks like as well. So, and the raw, in the raw data, open, I want to, in programs.
Were you looking for like Notepad?
Yeah.
If you go back, it should be in the other programs.
Oh, right. Other.
Well, no, if you cancel this and go back to the original opening screen,
Yeah.
should be
So
under Java
Yeah, click that. There you
Oh,
go.
there we go.
and a Notepad.
There you go.
Or WordPad.
Yeah,
thing.
either one.
So remember, this is what the raw data is going to look like. So we have the at relation weather. This is what's read in. Here are your attributes. We have outlook, temperature, humidity, windy, and play. And then the rest of this is, I think there are 14 different instances here that are going to get loaded. So that's the file. And then when it's loaded into Weka, here's what you get. And again, you see those 5 attributes. And here, basically what you're doing, right now we're looking at some visualization, and we can choose different attributes to look at. We'll talk about how this actually, the visualization works. That'll be probably on Friday or Monday. But what I want to talk about today is, so we've loaded up the file, and suppose we want to, so we took a look. Here's again the raw data. So one day it was sunny, temperature was 85 degrees, humidity was 85%, it was not windy, and the decision was not to play, right? So we've got these 14 instances, and there are a few things I want to introduce with this example here. And so I want to use that data to start classifying. So up in the left-hand corner of Weka, we see we've got the classify, we can cluster, associate, as we talked a little bit about earlier. So we're going to choose classify. And again, notice we have a number of options. I don't have a training set here. Okay, that's, if I had a separate training set and a separate test set, we could use a training set. What we're going to look at, and I haven't talked about this yet, is what's called cross-validation. And if I go back, I'm going to back up just for a moment, and I'm going to bring up the whiteboard. Okay. So I'm going to talk a little bit right now about what that cross-validation means. And so in this example, we have only 14 instances. That's not a lot of data. And the basic idea of cross-validation is that you're going to use your data as both training and testing. And essentially what you're going to do is you're going to, so let's see if I can do this. So say you have a bunch of data here.
Why don't you just use your finger on the board?
Because of half the time I use the board, it quits working after I use it for about 5 minutes. Does that answer your question, Nick? So here's like a bin of data here, okay? And the way cross-validation works is I'm going to split it, and there's different ways to do this. I'm going to split it.
Use your finger.
Yeah, just.
No, it's not like enough down at the bottom, so it's not recognizing it.
And see, this is the problem right there. It was green when we started, and there's something about Saba meeting and the smart board that interferes. I mean, basically, what you have to do is reset the whole smart board. Right.
And
So basically what we're going to do now is split the data into 2 pieces, and we're going to use part of this as your training set. And then the rest of it is going to be your testing set. And there's a couple ways that we can do this.
This is all about the. Yeah, or
Pardon?
this is for reference, right?
This is in general, this cross-validation idea. Typically, and you're going to reuse, so some different ways to do it. There's called threefold cross-validation or tenfold cross-validation. So let's look at, say, tenfold. So what you're going to do is you're going to break it up into 10 pieces, and you're going to use one of those pieces. You're going to train it on, say, 90% of your data and test it on the remaining 10 set. 10%. But then you can switch those groups around. So you've done one set, now you can use a different set for your training, a different 9 pieces for your training, and then the last piece for your testing.
Okay, so for your training set, it's always gonna be the majority of your data?
Typically, and you can set that within Weka, and we'll see how that changes things.
Okay.
Okay? So I'm gonna go back to share desktop. And moving on,
Back to Weka or?
back to Weka. Weka Explorer. So notice we've got here cross-validation, and we can specify the number of folds. So I talked about 10-fold, or you can do 3-fold, or, but you can also do a percentage split. So a 66% split would be 2/3 for training, 1/3 for testing. So you could get 3 rounds out of that.
Okay, so, and then you can choose which one you're using?
You can choose either, the number of folds or a percentage
Well,
split.
either the training set or the test set. Is that what?
No, I mean, you're gonna use, if I did 66%, you're gonna use 2/3 training, 1/3 test.
Okay.
Now you're going to use that test in a different, as part of a different 2/3 of training, and use a different third for tests. Does that make
Okay.
sense?
Yeah.
So you-
So it's
So you
like,
can do your number of folds or percentage split, it's just a different way of doing the same thing.
it's weird, it's like testing it and then.
You're reusing your data
Yeah,
multiple
you
times that way.
reintroduce it and retest it over and over.
Exactly.
And the number of folds?
So if you don't have a lot of data, if you don't have enough data to set aside your own training set, this is a way to generate more data from just a small amount of data.
Is the number of folds, how many times you reintroduce it?
No, so a 10-fold would be like a 90-10 split. So that would be a percentage split of 90%.
Okay, so the percentage on the fold is the same thing?
They're really just a different way of looking at the same thing,
Okay.
okay? And there's some more options. One of the things that you want to look at here also is, in this particular example, the decision we want to understand is, given the weather, are we going to choose to play, right? But you can choose so the play here would be our class, the one we're interested in classifying, play versus not play, right?
So,
But you could split, maybe you want to use play as an attribute to decide whether it was sunny that day. So you could also look at that, because you can choose the other attributes as your class. But in this particular problem, we're originally interested in, given the weather, are we going to play or not?
So we can look at the correlations between our class and each attribute. Is that,
Well, let me continue, and maybe this will become a little clearer. So we're interested in if it's sunny, if it's rainy, probably the decision will be made not to play, right? So we're going to use play as the topic that we want to be classified. Given the other information, are we going to go out and play today? Okay? The other thing is, what classifier are we going to use? So at the top of the page, we have a choice of which classifier we can use. And these are the different algorithms that we can choose. And there's a lot of different algorithms. So if I go to, if I click on that choose at the top, notice we're at this rule here, 0R. That's a particular algorithm, and we'll talk about specific algorithms as we go further into the course. We're not at that stage yet. So we've got, there's algorithm after algorithm. And we're gonna go through a couple of these today. I'm gonna start off with just that simple one to start, the 0R, the default. So let's start and see what happens, right? What do you think we do to start?
Push start.
We push start, okay?
It's a good call.
Good guess.
I would never thought of it.
Okay. So here's our output, right? We correctly classified 9 out of the
Yes.
9 of the 14 instances. We incorrectly classified 5.
So what does that mean?
That means you had 64% correct classifying from the weather conditions. How well did the computer do in deciding whether the weather conditions warranting you going out to play?
So the incorrectly classified instances are where the machine,
This would say play, and you really don't want to.
okay,
Or, what's the other option? It said,
You don't
it's a
play.
gorgeous day outside, the weather's not worthy of playing, but you think it really isn't.
okay.
Okay. Now, there's some additional things this example is really instructive. Because if we go down here, and this is what I really wanted, one of the things I also really wanted to discuss today, except for the technology problems. There's, at the very bottom here, we see a confusion matrix.
It's got me
Okay.
confused.
Cool.
And this is crucial also to understanding what's going on. Because if you look at the data here, okay, the actual results, notice this arrow, it says classified as, A is yes, B is no. So that on the top, we have what the computer guessed, right? What Weka guessed as what we wanted to do.
Based on our.
And then on the rows are what the actual data was. So here's the thing. If we look at this was a very stupid classification. What did the computer actually do every single time?
Said yes.
It said, go play, regardless of what the actual weather conditions are. Okay? And I just want to contrast, even, so it's saying, on the bad days, it's saying go play, on the good days, it's saying go play. Hey, it got 64% accuracy. And I just want to finish up, because the technology kind of messed with our time today, but I do want to finish up choosing a different classifier. I'm going to choose a BaseNet classifier and just see how the results changed. On this confusion matrix, notice now it didn't always classify the same thing. 7 classifications were correct here for, it's saying go play, and that was the correct decision. 4 times it said to go play, but that was a wrong decision. 2 times it said to go play, and that was a wrong decision. And 1 time it said to go play correctly. The correctly classified instances, it's not as good in terms of the percentage, but it's doing something a little bit more than the other one. So just something to be aware of on that example.
How do you determine which classifier to use?
We'll talk about that as well. There are many different classification algorithms, as you saw. So, an abbreviated session today. Hopefully next time the technology will work better.
Next 3.
So,
Put it in the public.
In my diner.
You don't put it in your diner, did you get one?
Questions in Daytona or Alamosa?
Hey, can I start giving you like good grade papers and handing them up on your fridge?
Sure, I'll do that.
Yeah.
Are we gonna go?
Pardon?
It's in my book, it's supposed to be very hard. Yesterday.
So the other thing, I have a video camera that seems to work better for recording my voice. Yeah, huh?
Next, for this coming Friday, I'm going to be out of town. We're going to Key
What, James?
for some kind of project there. I'll be back on Monday. So,
But the students, will the students be there?
yeah, Friday, I'm going to be out of town. And our student, the lady and the head are going to help us set up the connection. And I'm going to send you the link. Please send it.
I see you back there. Okay. Hopefully we'll have better luck with the technology on Friday.
Yeah, all right, I know that. It's a problem. So,
They turned off the audio. Was that coming together at the end there, Pablo?
Yeah, yeah. What was I thinking?
But you saw how Weka takes a lot of the effort out of the,
Right, the thing,
because you don't have to, it's already there, you don't have to do the programming to figure out Bayes stats.
so,
We'll talk about the different algorithms, some of them, we can't go through all of them.
So it takes data and it decides, well, yeah, I guess it's what? For this problem, it was making a decision.
Right.
So, well, depending on which classifier you use, changes the accuracy.
So I'm gonna log off and, well, they're right, I mean, you're gonna use different classifiers because they use different things, sometimes one works better than another. Let's see, how do
I just feel like it'd be difficult for very large quantities of data. Because like, how would you know
Well,
when it's
Did I
right?
just screw
You
that up?
know?
well, what I'm wondering is, like, do each algorithm have their own problem that they're better at solving?
Right.
Like,
Yeah.
if it's something just as simple as, is it sunny? Is it not raining? Is it not windy?
Right.
There's this one that's, fairly simple, but yet,
See, yeah.
this
I
more
agree.
complex one would get tripped up by that.
Right? See, and that's why I was. Okay, so the different classifiers have to apply to different problems or else there would only be one, right? So,
It didn't save it.
huh.
Camera starting back in the head.
Damn.
No, wait,
Alright, see you, Dr. Cook.